Okay, here's going to be some notes about the lecture slides from section 1.5. I'm going to run through them kind of quickly here and go through section 1.5. These, observe with me. I'm going to talk through them, and we've kind of talked a couple of these things already in class a little bit, but let's go on through the slides that I've got written here, and we'll notice it saying it's talking about infinite limits, limits at infinity, and asymptotes. All right, so here are the key situations we're talking about. Find infinite limits. We've got a function as x approaches 0. We've got the value of 1 over x squared. We've got x in the denominator, constant on top. So as you get closer and closer to 0, as this denominator gets smaller and smaller, when it's 2, x is 2, you've got 1/4. When x is 1, you've got 1, so it's getting bigger. When you've got 1/2, x is 1/2, you square it, that's 1/4. Flip and multiply, that's 4. It's starting to climb, okay? As you get closer to 0, the thing takes off. The fractions get smaller and smaller, and as a result, you're getting numbers less than 1 here, getting smaller and smaller. This is bigger than the fraction, you know, and as a result, the number starts getting huge when you get really, really tiny, okay? So as from the right-hand side, it's positive, and from the left-hand side, it's also positive. When you plug in negative values, you get the same exact thing, you know, when you square it, as you would if it was positive. The limit as x goes to 0 is positive infinity. It's going up from either side. Check it on your calculator. You can verify that yourself. Now, let's get rid of that squared, and you've got 1 over x alone. Well, this time, when you're coming from the right, then the answer is positive. When you're coming from the left, as you're approaching 0 here, this thing's getting smaller and smaller and smaller, and the fraction's getting tinier and tinier, and therefore you're flipping and multiplying, and it's taken off, up, when you're coming into 0 from the right, from the positive side. From the negative side, this isn't squared, therefore it's negative. And you're going the same way as you're going here, except it's going down, negative infinity. So you've got one-sided infinite limits, it's called. One on the right-hand side, coming from the right, it's positive. From the left-hand side, it's negative, right? And now, one statement they make here is there are 4 possible, dealing with going to infinity, 4 possible one-sided limits. And one is, if you come in from the left, you approach C from the left, from the negative side, you go to positive infinity. As you come in to approach C from the left, it goes down to the negative infinity. From the right, positive infinity. From the right, negative infinity. That's just the point of infinite limits, when the limit is going to infinity. Now, an example of it is if you're asked specifically, it depends on what question you're being asked here. This says, find the limit as x goes to 2 from the left of this function. X goes to 2 gives us 0 on the bottom. So we've got a problem. And that means we're going to have, it's going to end up being an asymptote, all right? That's going to be an asymptote at x equals 2 because it can't be that. But is it going to be positive or negative? Notice on top, if you plug 2 in on top, you get positive 7. That's not the issue. You come towards 2 from the left, that means 0, you get negative 2. 1, you get negative 1. Anything smaller than 2, the answer is going to be negative when you subtract 2. Positive on top divided by a negative, the answer is going to be negative. And it's going to infinity, so it's going to be going to negative infinity. That's the idea behind that, okay? So you got to pay attention to which side is it coming in from. Left of 2, the answer is always negative on the bottom. This is always positive on top. Negative on the bottom means the answer is going to be negative, and that's going to be negative infinity. Whereas, and the vertical asymptote we were just talking about, x equals c is a vertical asymptote if any of the following are true. If you come in from the left, function goes to infinity. If you come in from the right, it goes to positive infinity. Or if you come in from the left, it goes to negative infinity. Or if the limit as you come in from the right, it goes to negative infinity. Now, those are called asymptotes. And for rational functions, a vertical asymptote may occur where the denominator is equal to 0. May occur, being careful to not say always, okay? But where the denominator is equal to 0, that's causing the asymptote situation. So the first thing you look at here, where's there a problem? Yes, denominator can be equal to 0 if x is equal to 2. Therefore, as x approaches 2 from the right or from the left, it equals, it goes to infinity in both cases, positive infinity. It's the vertical asymptote. X equals 2 is a vertical asymptote. That's the actual equation for the asymptote. Okay? And now we talk, those are all talking about going to numbers, and the answer is infinity, going up to infinity or down to negative infinity. Now this situation, now we're starting to talk about what when you go out to infinity, where's the function going? And if you've got 1 over x, notice this. That is, x gets bigger and bigger and bigger, bigger and bigger, 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 bigger. You know, 1 over 1, 1 over 2, 1 over 10, 1 over 100, 1 over 1,000. It's getting smaller and smaller. Never get to 0, but it's approaching it. So the limit as x goes to infinity is 0 from above. Similarly, if you go in the negative direction, x is negative, so you're on the underside, but it's still coming up and going to 0. So in both cases, if you're going from the positive side or the negative side, it's going to 0 as x goes to infinity. Okay. Also, now some examples here of using that. Using this fact that 1 over x goes to 0, whether you're going to the right or to the left. Well, look here. Okay, so at infinity, we've got this function. What's the limit as x goes to infinity of this? 3 plus 2 over x. Well, let's split that up. The limit of a sum is equal to the sum of the limits. That's one of the rules that we had. The limit as x goes to infinity of 3, well, there's no x there, so that's just 3. The limit of this, we've got 2 over infinity. You know, it's not over infinity, but it's going to, as it's going to infinity, this is getting huge on the bottom. Therefore, this is getting smaller. It's going to 0. So this is 3, this is 0. The answer is 3. All right, and the idea is you can look at this initially and recognize 3 plus 0. You can go to this immediately and see that that's the answer. Now, in this situation here, pay attention here, because this could be written in different ways. But the denominator, they've got a fraction out front, a denominator, a single term denominator, just x's, just one term. Notice what they do. They get the 1/5 out of the way. They take, you know, the constant times the function is equal to, bring the constant out front, and then split this up. You've got 3 terms on top, 1 term on the bottom, split it up into 3 fractions, simplify, and you end up with this arrangement here now. X in the denominator, this is going to infinity. This is going to 2. This is going to 0. And this is even cubed. It's going to 0 faster, but it's going to 0 also. So you end up with, and again, you've got the limit of a sum is equal to the sum of these limits. And you add those together, and you end up with the 1/5 out front times 2 plus 0 plus 0, and you end up with 2/5. Okay? Now, check out what they do here on this one. Then notice the largest power. We got 1.5, half, 2/3, and 2. The largest exponent is 2. So if you divide the top by x squared, the 2, and divide the bottom by x squared, in other words, by each term by x squared, you end up with 1.5 over 2 is 1/2 left over on the bottom. That's, you know, negative 1/2, which pushes it to the bottom. 3 stays up on top, and you get 1/2 left in the denominator. 1/2 on top, 2 on the bottom. That's 4 halves. That makes 3 halves left over on the bottom. Got it? 5 over 3 halves. And then you've got, in the one term here where they're the same, you've got x squared over x squared. That's 1. Bingo. And here you've got 2/3 over, what is that, 6/3? That leaves 4/3 on the bottom. So you end up with these fractions, and as x goes to infinity, this becomes 0, this becomes 0, this becomes 1, and this becomes 0. So you end up with 0 over 1, which is 0. It doesn't, it doesn't become 0 in the denominator. It comes to 0 because it's 0 on top and an integer on the bottom. So the answer is 0. Okay, now if you've ever got a polynomial, it's always the limit. If you're going to infinity, positive or negative, you can disregard everything except the lead term. So you look at, if they're a polynomial p, the lead term is a sub n x to the n. You've got the thing, the polynomial looks like this. That lead term is determining where it's going. So you look at this term and it's going to be equal to, where this polynomial is going is this times the limit of this as x goes to infinity. So that is the end result there. And in this, we're going to look at a couple examples in a minute. If you got a rational function where you get a polynomial over a polynomial, then the circumstance is that you end up with, again, the lead term over the lead term. You take the limit. They don't have to be the same. But all the smaller stuff gets put away. The largest power needs to be here. The largest power needs to be here for the denominator. And as a result, the limit of whether it's going to positive or negative infinity is you worry about the lead term of the top over the lead term of the bottom, and you end up with this situation here. So one example, there's 3 examples that they give. One is the exponent is the same. The largest exponent's the same. Therefore, you disregard the rest. The limit as x goes to infinity of this. All you're worried about is the 2x cubed over x cubed. Bring the 2 out front, and you get this. This is equal to 1. The limit, this is equal to 1. The answer to this is 2. When they're the same, it's going to be the constant that's out, the lead term is the situation. And this one, okay, we got the power is larger on the bottom. Okay, the power is larger on the bottom. Therefore, all you're worried about is the lead term. These fall away. Therefore, the lead term, all you've got is the 3 out front times x squared over x to the third. That leaves you 1 left over on the bottom. That means this is going to 0. So you've got 3 times 0. This is 0. So always, if the denominator exponent is bigger than the numerator exponent of the lead term, then the answer is going to 0. That's going to be the case. And the graph, notice this is kind of unique. It comes up over the axis and then comes down. This starts under the axis and goes up. It's kind of an entertaining kind of picture there. Okay, and then the third term, so this one was, the first one was the exponents are the same. This one is the exponent on the bottom is bigger. This last one is the exponent on top is bigger. And if the exponents on top is bigger, disregard everything else, you're left with just this, which means you just have this. That means you've got, when you simplify that, take the 4/3 out front, right? Then you've got x to the third left over, and x goes to infinity. That's taken off. So if the exponent on top is bigger, it's going to infinity. If the exponent on the bottom is bigger, it's going to 0. If the exponents are the same, it's going to the lead coefficient, what you end up with that situation. All right? So, and there's a few applications they give here. I'm going to skip through that right now. We'll talk about those in problems in class. But horizontal asymptotes, real quickly, as you go out to infinity to the right and negative infinity to the left, it's got a horizontal asymptote if, as you go out to the right, it goes to some constant. It levels off to some number to the right or to the left. So example of this situation right here, as you go to the right, it's leveling off down here to M. That isn't horizontal asymptote. It never quite reaches that, okay? And up here, it never quite reaches L. It's always below it, getting closer to it when you go left. So the situation is, an example of it is this. When you've got this function, again, all you're worried about is the lead term. You're only worried about the lead terms. This stuff goes away as you go to infinity. They become insignificant enough that all you're worried about is the lead term. So it turns out that you end up with 7x over 3x. The x's cancel. You've got 7/3. So the line y equals 7/3 is the horizontal asymptote. In that situation, you look at the lead term. These two are the same. It's going to 7/3. That's where it's going from above and from below, okay? And then you've got the situation here. Let's watch this one. This is the last example. They do a few different things with it, though. Notice we've got the same exponent in front, okay? And you kind of get the sense that it's going to 3/2 is what the answer is. That's where it's going. But the question is, find any asymptotes. Are there asymptotes to this? Is the denominator equal to 0 anywhere? Well, here's a situation where you've got denominator equal to 0 in two different numbers. So the domain can't be 3 because you can factor this into two factors. And this one, the factor is what, 7/2? And this one is 3. So x can't be those values, but are there asymptotes in each case? Notice the x minus 3 is going to cancel with one that shows up on top. And as a result of canceling with one on the top, again, like we had an example in class the other day, our situation was it was a line, there was a hole. So there wasn't an asymptote, but there was a hole. So in this situation, it will turn out that this one provides an asymptote, the 2x minus 7, but the one that cancels is just going to provide a hole, okay? So there's two places x can't be in the domain, 3 or 7/2. One has an asymptote, the other is a hole. So if you look at the example of 7/3, 7/2, if you come in from the left, this is kind of an interesting point to get as well. The issue is that the x minus 3's cancel, so you're only concerned about what the portion that's left. Take the 3 out front, and it's just going to be this over this. Now, as x goes to 7/3, this is going to be positive on top. But as you approach 7/2 from the left, okay, that's negative 3.5. That's like negative. So if we come in from 3, this is 3.5. So if we're at 2, that gives us 4 minus 7. That's negative. If we're up to 3, that's 6 minus 7. That's negative. So if we get up to 3.4, this is 3.5. If we go up to 3.4, we get a negative value in the denominator. So, and this is always positive on top. So the answer is going to be it's going to negative infinity. Whereas if you come in from the right and look at this situation, we're at 3.5 again, 3.5. So if we go up to 5, that's 10 minus 7. That's positive 3. If we come down to 4, that's 8 minus 7. That's 1. That's positive 1. It's positive. If you have any number bigger than 3/2 plugged in here, it's going to be positive. So as a result of this going to infinity, it's going to be positive infinity because it's coming in from the right-hand side. And the denominator is always positive. This one, the denominator is always negative. So it goes to negative infinity. It's kind of an interesting point. You might want to take a look at that. But notice what happens as it comes in, the x minus 3's cancel out. When you have what's left, you plug and go to 3. It turns out that you end up with, 6 here, 18 over negative 1, and that ends up giving you negative 18, right? So it does not have an asymptote there as x goes to 3 when those cancel. So as a result, that's evidence of the hole I was talking about. You can see that from right here. You know it's going to cancel, therefore it's going to be a hole there. This one will have an asymptote because it doesn't cancel, okay? That's going to be the situation in those cases. And now if we're talking about a horizontal asymptote for this function, again, it's a matter of looking at the lead terms. X squared over x squared, disregard the rest, you're left with 3/2. 3/2 is where the asymptote is. Again, use your calculator, graph it, take a look at this thing, and you'll know the answer by looking at it, okay? So that's it. This is section 1.5.